Hello fellow problem solvers. So today we're going to be doing a problem from the United States Mathematical Olympiad 2011, problem number 4. I suggest you try this nice number theory problem out for a minimum of 20 minutes, ideally 45, but not more than an hour and a half. If on the other hand you'd like to go along with us, I suggest you give it a go for the next 10-15 minutes. Put your first ideas out on paper. And now, without further ado, let's begin. So what I like about this problem is that it gives you a question. Is 2 to the 2 to the n congruent, is the remainder when you divide this number by 2 to the n minus 1 always a power of 4? It's a very cool problem. Like, it doesn't tell you if it is or it isn't, it tells you find out. So, and that's like what most life is about, you know, like if you're doing actual research, you're like, you don't know what the answer is. Is it not? Who knows? And how will we find out? So, well, let's explore what this is modulo this. So the first thing in number theory, well, 2 to the n is congruent to 1 modulo 2 to the n minus 1. So given both these two things, you'll have 2 to the 2 to the n is congruent to 2 to the 2n minus n times 2 to the n, which is 2 to the 2n minus n. And now we can continue doing this all until we reach number 2 to the 2 to the n modulo n, like what this number is modulo n, and that's the final congruency, right? We can't go any deeper anymore down. And this number will also be, what's it called? It will be what the remainder is because it's less than this, right? Because modulo n, this number will be at most n minus 1. And so this number will be less than this one. So this is what our actual remainder is. And now the question is, really, is 2 to the n modulo n. If this number is always even, then the problem statement is true. If we find one of them such that this is odd, then we've also finished the problem, like we've found a counterexample. And now, let's look at counter. Like for evens, we're done. For primes, it's also even because 2 to the p is congruent to 2 to the p for Maslow's theorem, like modulo p. And okay, so with that, let's look at, well, we have p squared, and we're looking at 2 to the p squared modulo p, and p times q. I mean, let's see. Can we have this in general, 2 to the p squared modulo p squared? What is this? Well, we know that phi of p squared is p times p minus 1. So 2 to the p squared is congruent to 2 to the p squared minus p times 2 to the p is congruent to 2 to the p modulo p squared. And now, so for free, we have 8 is congruent, like this is congruent to 8. And so for 5, we have this is 2 to the 5th modulo 25. And this is what? This is 32. 32 is 7. Oh, and here's a counterexample. We're done. I mean, just like that. Huh. Well, this solves our problem. That was a bit anticlimactic, but it's a cool problem. Okay, so now where we would write the solution is say, we know that the remainder is going to be this. So we're interested to see if this is going to be an even number or not. If it's an odd number, it's not a power of 2. And we have that this is true. So now we can also write down 2 to the 2 to the 25th is going to be congruent to what? It's going to be congruent to 2 to the power of 7 modulo 2 to the 25 minus 1. Ergo, there's a counterexample. Or ergo, assertion false. And this solves our problem. It's a cute problem because like it gives you like some taste of, you know, like what actual life is like. You know, you don't know if you can solve something or not before it's solved. And this solves our problem. And as always, thanks for problem solving.